Welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. Okay, we are still developing a MachO reader to generate our code. So, well, some, a very tiny amount of code. Let's go. Good. So we said we want to generate classes from functions. Just a class definition. Okay, how do we do that? We probably need this here as well. All right. By the way, before we go in here, why is everything so slow right now? Jesus Christ. Let's remove this garbage here. What I'm thinking is, I was wondering, is it actually safe to have string views onto the string? Because if this string has small string optimization, then these guys would refer to this. But if this would reallocate inside the vector, then those pointers could be pointing to the wrong thing, no? So I think this is not safe, and we need to make it std string actually. Yeah. I always try to be fancy, but sometimes that is not possible. So I think what we do here is function base name buffer buffer buffer, right? Buffer. There we go. And then we remove this and this. Let's double check that we didn't break it. Somehow everything is really slow here. Machine is breaking. Okay, let's see. So your buffer, memory pool object, and that looks good. Yeah. Buffer, memory pool object. All right. Then we got that. Okay. So, what do we want to do? We want down here generate classes from functions. So, let's copy this one here and function dot ab. The context name. The context name, yeah. Okay. The context name. Okay, so I think what we do is declare context name. So find or create class by name, right? With this name. And then That's it. That's all we need to do, I think. If I'm not mistaken. Let us check if this gives a desired result. So we go to watch. So we have m classes is 0, empty right now. Yeah. Okay, so now we have how many functions? We have 21,000 functions roundabout. Okay, and then here we now create functions. It has no name. Bill? Me? Why? What did we create with here? Hold on. Function. Ah, okay, it doesn't have. Okay, so we need to say if not this empty, then we create a class. All right. But there is a problem, no? No, maybe. I wonder if we go in here by mistake at some point. We will see. Okay, so it's empty, so we don't create anything. This one is empty as well. Okay, here is the first one. Here it would have to create a memory pool object class, right? Memory pool object class. Okay, so we go in here. It won't find it. It creates it. There we go. Push back. Yes. Index. All right. Name. Okay. Limit. Okay. Position. And nothing. Okay, good. Okay, this seems to be good. Let's put a breakpoint. Put a breakpoint. Oh boy. Here. And let's have the breakpoints in here. Remove this breakpoint. Aha, we hit here. std. Okay, call stack. Generate classes from functions. std vector. Okay, std vector. This is actually correct that it would create a namespace now with std. Okay, that's fair. That is fair. Mm-hmm. Okay. Mm-hmm. Namespaces. Mm-hmm. 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 Okay, let's keep on going. Okay, we have another one, another std, and this one already exists here, and so it can create here 18. Uh-huh. Uh-huh. Mm-hmm. std. Okay, what do we have here? Parent class, parent name. Oh, what? Okay, std somehow is a class now. Oof. How did that happen? How did that happen? I don't know. Somehow the parent name is std. Parent name std. And we have I'm confused. Okay, let's put a if name equals std, then int a equals 0, and we put a breakpoint. Okay. So we have std namespace now. And now we have std class. Oh. Function is void std. Push heap. Void std push heap. Okay. std. Okay, std. 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 How do we deal with that? Okay, so basically it's a function in the std namespace, and then it wants to create a class with that. Maybe we need to say here that if can so our namespaces contains std. generate classes from functions. The only way I see here. It's a bit of strange because it relies that std is already known as namespace by then. If you would filter here for namespace at this point, that's a bit strange. How do we do that? There must be some somewhat elegant solution, but I don't see it right now. I don't see it. We want namespace. It has namespace. Well, we can always hard code that std is a namespace. That's not very reliable. Luckily, the game doesn't have any other namespaces, so at least it's like there's not much complication from that angle. Oh, how do we do it? So, the declaration context name is std. How about we say, we could say if the name is lowercase, we treat it as a namespace. If it's uppercase, then it's a class. Buh. It's also, I mean, we can't make this assumption. Okay, but the easiest fix I see right now is that we say if if here this name, if this dot find is not, or is dot end, right? Let's put it in a boolean. Is namespace equals that? What is, yeah, is namespace bool. There we go. And then if not is namespace, Okay, so this would probably work. Let's see. Let's see. Okay, so SCD is added as namespace. Yeah. Again, again, again. COpenGL is added as namespace. That's not right. That is not right. Oof. Um. Do we perhaps need to run this? Do we perhaps need to run this after this one here? Or will we have a different kind of problem then? Oof. There could be other problems, maybe. Okay, so now COpenGL is added as a parent class. Okay, that's good. Okay, SCD is added as a namespace here. Here we have added a simple object iterator class. And here camera shake system is added as namespace, which is wrong. Oof. How do we deal with that? dict. Dict pair. What is that? Type info for dict. Doesn't exist. Dict pair. What the hell is dict pair? It is a class. Okay. Oh man, it's too much. How about we say put here if if parent name is not std and parent name is not GNU CXX, int a equals 0, put a breakpoint here, boom. Okay, so camera shake system class, BW render class, dynamic VB access class, stripify. What the hell is that? Stripify. Strip, is that a class or not? Oof. Strip could be a namespace or a class. Oof. Strip vector 3i. What is that? That's weird. That is extremely weird. Vector 3i. Okay, I'm a bit confused about this strip thing. I wonder if that is already in Thyme. Strip. Generate classes from functions. Strip. Strip. Oops. Stripify. No, it's not in here. I don't know if it's a namespace or a class. It's hard to say. Strip. This is also weird here. Like, is this even a class? Because if this was a constructor, it should be uppercase and not lowercase, right? I'm confused. Maybe this is both a namespace. This is a namespace and this as well, maybe? Hmm. 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 We don't know. Okay, so there is strip, stripify. Yeah. Generate classes from functions. Deckel context name. I mean, this can also be stripify. Generate okay, this is a little bit complicated. How about we do the following? We first figure out what is wrong without this one here. Let's remove this. And let's see what is wrong there. Yeah. To get this right first. Because here we definitely know that these guys will be classes, right? That come through the type info. Yeah. For the others, it's a little bit of a guess if it's a class or a namespace. We're not really sure. Yeah. Okay, but here we would be sure. So we probably should run this first, yeah. Okay, let's see what hits here. It's probably the shaker class or whatever that was. Yeah, the shake system class. Let's see if there's anything else. No, it's just this one. Okay, then how about we say we hard code a condition here. And we say if ends with parent name class. Yeah, if it ends on class, then we know it is. Oh, hold on. Let me keep this debug here. If that. So we say if ends with class, then then let's put here a hard-coded condition to treat parent as class. Catered to ZH. ZH game. Okay, and then we say else this. Okay, And then here we say ZHGame. And here we say find or create class by name, parent name, namespace, class index. There we go. Parent class index names m classes. This one should be called parent class index. Child class indices, pushback index. Okay. Hardcode condition to treat parent as class. Okay. Otherwise, assume namespace. Okay. Okay, so we got this one covered, this one case. And now let's get back to this one here. So we would say, where are we? Let's put this back. All right. So let's see. Let's put a breakpoint here. Yeah. Okay, so we got, okay, so this is pass pxt, and now it will go in here and add that class. Parent name, camera shake system class. There we go. Okay. Now we got BW render class. BW render class, and this one also goes in here. Okay, and this one is coming from this one. BW render class. Okay, so that's fair. Then we have dynamic VB access class. That one also goes in here. This is also good. Then we have a strip, parent name, strip. Okay, but this is only concerning parent names. Can we go back once more? BW render class, what is the name? Buffer. BW render class buffer. Yeah. Buffer. So there's a buffer class inside this BW render class. Yeah. Okay, but with in the case of the stripify, how do we know that not both are? buffer, function, buffer. So it's a constructor, buffer. Yeah. Buffer. Let's search for BW render class buffer. Okay. Yeah, we can clearly see that this is a class because it has a destructor here. BW render class. We see a camera shaker class, or what it was, shaker class here. This one. I think we can also determine if it's a class if we can see that we have a constructor and destructor. Maybe we should do that. This one. I think that would be a better way. It's probably more expensive. Yeah. It is more expensive. Probably. But maybe it's more accurate instead of making assumptions. So here function, we say bool m is citor or ditor. Yeah, false. And then here we say mangler function dot m is citor or ditor, and the mangler is citor or ditor. There we go. And then we say, we create a function bool const bool has citor or ditor. Has citor or ditor. And then we give a const std string name. And then we say that we have to loop basically through all functions. Yeah. This will be expensive. Well, it's okay. It's okay. It hopefully won't be too many cases here. Has CTOR or DTOR? Okay, so, and we say function dot name dot, we say if begins, if starts with, function, if starts with function name, then if, or we say and function dot m is CTOR or DTOR, then return true, otherwise return false, right? Okay, and then we say here, so instead of hard coding this name here, we then say if has CTOR or DTOR parent name. Wait, before we delete this, let's comment this out. And we say if has CTOR or DTOR parent name, and then we should know that this is a class if it has a constructor or destructor, right? Okay, let's put a breakpoint there and see if that works. But we should probably do the same here, this check here, but let's check it here first. Oh. Why are we here? Ooh. Okay. So apparently SCD has a constructor or destructor. Now that is wild. SCD. Huh. Ugh. Okay. Let's put a breakpoint in here. Oh, I think I understand. Yeah. This is a destructor. And it starts with STD, and so it thinks, no, but this is not right. We need to say function dot decker context name needs to match that. Yeah, decker. Okay, so we need to say function decker context name equals name. There we go. Let's try that again. Okay, so camera shake system class. So now we expect that this one returns true, right? Let's see. Here, we expect that this hits now, and it does. Because we have a camera shake system class, and the function is a constructor. Great. Okay, so we definitely know that this is a class because it has a constructor. And then we create the class here. Okay, that's great. That is great. Yeah. Then the next step is, so this works. Then what we do here is if has CTOR or DTOR, this one here, if has that, then we will do this here. And we won't do this. Right. Actually, it's namespace. If we already know that we have a namespace, yeah, let's say, actually we can keep this condition here. We say if not namespace, and then we say this one here. Let's make it a const. So if not is namespace, and then it checks if has constructor or destructor. Generate classes. But we also need to create namespaces, right? Namespace. Okay, let's remove this here, and this, and this. And I think we need to make some change to our namespace creation here, because this one can also have this. Let's go to namespaces. std string m namespace name, and then we say AB becomes B. Let's go ABC becomes C. ABC becomes C. And then here we do similar to what we do here. So name, pos. Then we say namespaces index namespace name. By the way, I think we should also class name. I think here we also need to say else class name equals name. Oh shit. And here we need to say else namespace name equals name. And so the parent name of a namespace should then also be a namespace, right? So there we simply say parent name. We say we simply call find or create namespace by name. So the same thing, recursive, and then we pass the parent name. Maybe that is enough. Let's put a breakpoint in here. This might hit with our stripify, right? Yeah, okay. Okay. Okay, we leave this debug here for now. Okay, let's see if this one is good now. It's quite complicated. Huh? Okay, so camera shake system class has constructor or destructor. Yes. Yes. And so we create a class. Okay, great. Then let's check the next one. Okay, what do we have here? Memory pool object. Oh, this is expensive here. How about we say let's do const bool is class name to class index finds that is class. How about we create helper functions here for these? Say bool is class const std string name is namespace. Okay. let's copy these, put them here. There we go. All right, MachO reader, boom, boom, and then we copy those conditions. Where are they? Here. Name class, return name, find name, and then we have this one here, return. There we go, name. Okay, and then we say if is namespace, and we say is namespace, there we go, and is class equals is class, there we go. So that's a bit simpler to read. And then we say if not if not is class and not is namespace. So if it's neither of these, then we go in here. Okay, but what do we do? If it doesn't have this, then we do else find or create namespace by name. Yeah, I think this makes absolutely totally sense. Okay, let's put a breakpoint here. Let's stop the debugging. Let's remove, well, let's keep this breakpoint here. Let's see. Okay, so camera shake, yeah, it goes in there, true, good, all right, perfect. Okay, F5, good. So is namespace false? Is class true? Okay, and that means we are done here, right? Because we already have a class. Perfect. Let's put a breakpoint in here and we hit it. MachTools. Okay, so we don't have a class for MachTools. Now the question is does it have a constructor or destructor? It doesn't. So it seems to be a namespace. MachTools. Let's search for it. MachTools. Find all. Yeah. Yeah, it can be namespace. Yeah. Yeah. Could be. Could be. Okay, that's fair. Then let's press F. Yeah, let's step in here, MachTools. So what this do? It will create a namespace. Yeah, namespace. Name, MachTools. Okay, so now we have std namespace and MachTools namespace. Okay. Okay. I think we are missing something here. here. We also need to link now. So we have an index T, class index. And here we have index T, namespace index. So we need to assign those guys to the function, right? Function dot parent class index. There we go. And then we also need m classes dot classes class index dot classes class index function indices dot pushback we need to have I think we need to for function for index T I function index 0 function index smaller than functions dot size plus plus function index functions function index pushback function index. There we go. And here we should say function dot parent namespace index equals namespace index, and then namespaces namespace index dot namespaces function indices dot pushback function index. Okay, and then we need to I think here we need to also do something. Index T parent namespace index, and then we need to say namespaces index dot parent namespace index equals that, and then we need to say namespaces parent namespace index dot namespaces class indices I think here we need to say do we put child namespace into a namespace? I don't think so. I don't think so. Or do we? I'm not sure. Maybe. Maybe not. Parent names. Well, if we have this relationship, then we should also have std vector index t child class indices. Yeah, so we say child namespace indices and namespaces in this namespace. Okay. And then here we say child namespace indices push back this one. There we go. Okay, I'm a bit confused now. I hope this is all correct, but it might be. Maybe. Okay, let's see. Okay, so we got this guy. Yes, we know this is already okay. Next. Okay, so next guy. MachTools doesn't have a constructor, so we go in here, namespace index 1. So the function parent index will be parent namespace index. Will be that, yeah. Okay, and then namespaces, function indices, so we push back this guy. Okay, okay, so we have built this relationship. Let's see more hits. st show cursor, and that is st show cursor. And that is a class. Look at that. That is a class. Class index, parent class index. Classes. std vector. Oh, this is not treated as a namespace. Uh-oh. That's not right. Oh. That's not right. So this must be a class because it does have template arguments. Yeah. How about we create a new function? We say bool is function. No, is class. Is class. Well, hold on. We already have this here. Is. How about we call it is. How about we rename this to is known namespace is known class, and then we rename this to is expected class. Yeah. And then in here we say is known class. Bool is expected class. And we say if name dot find the symbol is not std string and pos, then we say return true template has template syntax. If has ctor or dtor, then return true. Expensive has constructor or destructor. Otherwise, return false. Okay, and instead of is known namespace is known class, then here we rename this to is expected class, and we can probably optimize this a bit by saying function dot m is ctor or dtor, or this. So this one is like a little optimization. Okay, then we take this and we put it also in here. No, yeah. we say here is expected class. Okay. Then let's run this through. All right, so is expected class, yes. Return true. Good, so that's good. Next. Mac tools, we expect this a namespace, that seems to be fair. Next. st show cursor. It is, so here we go the quick route, because we already know that this is the constructor or destructor, and so we don't even need to look through all the functions. So it's a little performance optimization. That's good. That seems to be fair. Function index. Okay, next. Next we have this vector. Okay, and now this should also be classified as class, because it does have the template syntax. So this is a class. Yeah. std vector. std vector. Okay, next. Mac preferences. Mac preferences could be a namespace, and it is. Okay, that's fair. Mac preferences. Okay, that's fair. Mac resources. My gosh. Okay, Mac preferences could, resources could also be a namespace, and it is. Next, Mac folders. Mac folders also namespace, fair. Okay, here we have a class again. Okay. And here we have another class. And here Mac files could be a namespace, and it is. Okay. CM map file. Oh, this could be a class. I would expect that this is a class. And it is, yeah. It is a class because there is a constructor. Okay, good. st port state. Also a class. Okay, good. And another one. Okay, good. Okay, I like that. I like that. What do we have here? Mac builder could be a namespace. Okay. What do we have here? Mac memory could also be a namespace. Yeah. Mac globals. Yeah. Mac debug namespace. Yeah. C Mac log file could be a class, and it is. Okay, good. Mac log file probably also a class. No, that one is not. Why not? Functions, Mac log file, write message. Huh, I would have expected that the Mac log file is a class. Let's look at it. Mac log file. Um, there's an object as Mac log file. This one looks like a constructor. C Mac log file. Aha, okay, so this is a namespace, Mac log file, and C Mac log file, that's a class. Okay. Okay, okay, okay. So I think this is correct then. This is a namespace. Okay, let's keep on going. The vector, this one should be a class. Yeah. Mac display. That one can be a namespace. Yeah, okay. Opaque context ref. Okay, it's a class. This one is, oh, yeah, it's a class. Okay, yeah. This one as well, yeah. C display info probably is a class. Yeah, it is found here. Okay, excellent. Yeah, yeah. Okay. Next. This one is a class. Mac features could be a namespace, yeah. Win cursor. Could be both function or namespace. Okay, it's a function. Okay. Win icon. Same thing, class or namespace. It is a function, a class. This one is a class. Mac strings. This one could be a namespace, and it is, okay. CAE desk. Probably a class. Yeah, a class, okay. Next, CAE events, and probably also a class. Yeah, it is. Okay, I appreciate that. Then this one is probably also a class. This one as well. This one as well. Pixel shader manager. Pixel shader manager is probably a class. Yeah, it is. Var buffer, probably a class. Oh, no, that's not. Var buffer. Let's take a look at it. Var buffer. Okay, there is a name. Yeah, looks like there's a namespace and there's a class cvar buffer. That's a class. But var buffer is a namespace. Okay, that's fair. That's fair. Okay, next. COpenGL matrix, probably a class. Oh, it's not. Okay, that is suspicious. That is suspicious. COpenGL, what was it? Matrix? Matrix. Matrix. Find. Oh, it is a class though. Why is this we have a destructor here. Why is this not why is this classified as oh. I don't know. So we pass COpenGL matrix. Yeah, COpenGL matrix. COpenGL matrix. COpenGL matrix. And then our functions. COpenGL matrix. It looks like there is no function symbol here, the nFun, that refers to this constructor or destructor. Yeah. Okay. So I think we need to make we need to collect more functions here by the look of it. Some functions don't have the nFun symbols. Yeah. Looks like it. Okay. Yeah, yeah. Oh, but hold on. This one is in the other executable. Yeah. Maybe the constructor destructors are inline, so it doesn't know them. Yeah. Okay. How about is expected class? How about we add one more rule in here and we say if if name if not name dot empty and name 0 equals capital C for class, return true, assume class name starts with capital C. Well, it could be it could be deceiving. Hold on. C open GL. uh, and one is larger equal a, and name 1 is smaller equal z. No. Yeah. Okay, but that is quite some assumption. Assume class name starts with capital C and another capital letter. Let's put a breakpoint in here and let's see if that hits. So it should now hit for C OpenGL matrix, right? C OpenGL matrix. Oh boy. Okay, but up until this point, the detection was pretty good. All right. Okay, let's remove this breakpoint here. Okay, we have a match. See display info. See display info. CAE desk. C OpenGL matrix. Okay, now it's classified as class. This one as well. Oh. We should probably. We should probably make a change here. Let's move it here. Then we say pos name r find we say if pos is not std string and pos, else, there we go. We say if if name pos, wait, hold on, how about we say this? We say if pos equals that, then pos equals 0. And then we say this, pos we say else pos equals plus equal to pos plus 1 plus pos plus 1. There we go. I think this works. Let's simplify this to pos equal and pos 0, otherwise pos plus 2. There we go. Okay, let's put a breakpoint here. Maybe there's a chance that maybe I made a mistake and it crashes now. Let's see. Okay, see display info, so pos must be 0, yeah. Okay, that looks fair. Next. Pos is 0, name, okay, fair. See OpenGL matrix, pos is 0, fair. Okay, here now the pos should be different, 18, yeah, because we want to check the last one, after the double colon, the name, yeah. So this is expected class, yeah, okay. C text unit, okay, we probably expect that this is CRC. Oh, that is tricky. That is tricky. CRC. CRC. It could be a namespace, to be honest. Uh-oh. CRC. It could be a namespace, yeah. Oh boy. Yeah. Yeah, I'm not so sure that CRC is a class. It could be. It could be very well a namespace. CRC memory. Yeah. Yeah. How about we say we say assume class name starts with capital C and another capital letter. how about we say that if let's do for size t I equals pos I smaller than name.size, yeah, plus plus I, and we say if, let's say I, actually, hold on, so pos plus 2, so we say we expect at least one character should be lowercase. It shouldn't be just like all uppercase. Yeah, I mean it's quite a far stretch, but we bend it to what we see, right? Yeah. Assume class name starts with capital C and another capital letter, but is not all capital. Okay, and then we say if name I is larger than A and or no and name is smaller equals Z. There we go. Yeah. Yeah. Okay. Okay, let's see. So, see display info, yeah. Pass, 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 pass. Oh, what do we have here? Dict pair. Okay, so dict pair, we consider a namespace, which I guess is fair. Dict pair. Oh, but it can't be because it's this is a class. Okay, so dict pair is definitely a class, but dict could be a namespace. Yeah. Um. Yeah. So what we can do is we can look into arguments. Yeah. We can say name has ctor or dtor. We can say is function argument. Is function argument. Okay. And then we have another function, okay, okay. So we have another big function and we loop through everything. And we say if function dot function parameters yeah, we say if name, if function parameters dot find name is not std string in post. So if we find this in an argument, then return true. Oh, Jesus Christ. Return true. Return false. Oh boy. Is function argument. So we say here, if is function argument name, then it must be a class. Return true. And we also say expensive type is in function argument. Actually, this is not correct because now namespaces would be detected as function argument as well. Type is used as function argument. There needs to be we need to say size t position okay, and then we need to say and name pos plus name dot size is not a colon, right? Because if there's a colon, it means that we found a namespace as an argument, right? Okay, let's put a breakpoint in here. Okay, then let's see what we get now. Okay. Oh boy. Okay. Position 38. Oh. Oh. std. What happened? Name. Pos. Name. Huh? Oh. I see. There we go. Oh, this would be expensive. This will be extremely expensive. Because now it will search every item in there, right? Okay, so we gotta hit here, see display info. Okay, fair. Okay, is function argument var buffer. Yeah. var buffer is an argument. So pos 2. Oh, hold on, that's not quite right. Var buffer should be a namespace and not that. Uh-oh. var buffer. No, that's not right. I think we need to tokenize std tokenize no. Split. Oof. Let's ask ChatGPT for a solution. I would like to tokenize type names in function argument lists, such as, let's just come up with some bogus function, int star, are there spaces in there? Are there spaces in there? Yeah. Okay, let's say, where are we here? Int, it's to rect, let's do const, let's do class. I would like to tokenize type names in function arguments lists, such as int would become int rect class, would become int rect class how do we do that in C++17? Let's see what he suggests. Tokenize. Ugh. A huge function. Oh boy. IO stream. Jesus. Where's the IO stream? Okay. Okay. Oh boy. Okay, but yeah, we need some kind of helper function. Oh boy, still not done. Last token. I think the way we I think we can greatly simplify this. We just need to, so we skip the parentheses, then we take this word, and then we stop at either the star or the and, or space, or comma. And then we start the next word, right? Let's implement our own function. Let's say oh boy, that's so expensive though. Oh. Okay, how about we create a function here, std vector string std string, and we say here we have function parameters, get parameter types. Okay, const. Good. Okay. This will be expensive. Holy shit. Get parameter types. Function. So we say okay. Types. Return types. Done. Okay. Function parameters. Function parameters. Okay, so dot cstr. Then we do const char s. Yeah, or c. Okay. And we do while c is not null. Yeah. Okay, and then we say we say std string type. Okay. Then we do type So we say if C equals that, or C equals that, then we continue. If C equals star, if std is space C, or C equals star, or C equals that, then we end the word. Oh, Jesus Christ, formatting. Continue is space, then we say type wait, else. Okay, hold on. Continue. Or continue. Okay, down here we say type plus equal C. Okay, and then we say here if C equals comma, then we will type dot clear and continue. And here we do type. Here we do types dot pushback type. Right, and then we do also type dot clear and continue. This might work. Maybe. Yeah, get parameter types. Let's put that in here. Let's put a std vector, std string, and then we what is it? A function types function dot get parameter types. Oh boy, this will be expensive. Maybe we should pre-compute it once, because this will be madness here. Yeah, we will see. Okay, then we don't do this find here. We'd simply then do if we do for const std string type in types, and then if type equals name, then return true. Otherwise return false. Okay, let's put a breakpoint in here. I expect this will be super expensive. Okay, so we have std function arguments. Oh boy, we have a deadlock here. Okay, where's it hanging? Where's it hanging? Oh, we are never incrementing C. Right. Oh. Right, so we need to have 4 plus plus C. There we go. Let's try that again. Okay, let's put a breakpoint in here. Okay, let's see. So we have C. Oh, there's nothing in there. Okay, fantastic. Oh, that's wrong. By the way, this is wrong here. We need to say if this or this. This or this. Let's try this again. Actually, this is also wrong. I think this belongs in here. No, this is wrong. Okay, so if this opens, okay, we put a boolean invert or in type false. Let's say type opened. Then we say here type opened true, and here type opened false. And we say if type opened, then this. Okay, so the type opens if this opens or we have a comma. Yeah. And then the type closes if there's a space or a star or this or this. And then we finish the type. Type open continue. Yeah. Okay, I think this makes more sense. Let's put this like so. Okay, we need to step through a bunch and see if the algorithm works. Okay, so function. So this one has no parameter type, so nothing should happen here. Should just skip over and be done. Types is empty. Yeah. Okay, next one. This one also has no arguments. This one doesn't have arguments either. So this one is just open this, open that. Okay, so it goes in here. And then it essentially goes in here. And it pushes back nothing. Oh. Yeah, okay, so here we need to say if type dot empty, not empty. If not type empty, then push back. Maybe we can do std move type. There we go. I think then we don't need to clear here. I don't think we need this either. I think this should be enough. Let's try this again. Oh boy. Okay, so we have a function with no arguments. This is empty. Next. Empty. Next. This one has no arguments. So what should happen now is it goes in here, type opened true, and now it closes the type straight away and it's empty, so nothing really happens, and now we are done and we have 0 types. That was correct. Next. Let's try to find some parameters here. There we go. Unsigned long. Oh, okay, I see we have a problem here. Unsigned long. So we have unsigned long, unsigned. Okay, here we need to make a change. Unsigned. We need to say if space, if type equals signed or type equals unsigned, then we need to keep on going. Space. Space. So we say if one of these two, then we keep on going, continue, otherwise we do this here. Yeah, I think this would work. Let's try this again. Oh boy, this stuff is getting complicated here. Okay, so function types, next, 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 next. Okay, unsigned long. There we go. Okay, so we expect unsigned. There we go. There we go. Unsigned. Okay, so it's now unsigned, and now we should go in here because it's a space, yeah. And now it says type is signed or type is unsigned. So we should go into continue and skip over the space. Yeah. So now we continue with long. There we go. Oh, hold on. Then we need to say signed. Let's try that. Okay. Types. Okay, unsigned long, types, unsigned long. There we go. Okay, next, 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 short. This one should contain short, yeah. Next, okay, here we have two types. So here we expect an unsigned char and a point, right? Let's see. Let's just go quickly over it. Okay, oh, we just have one unsigned char. Okay, that is unexpected. Okay, let's see why that happens. It's because of the space, isn't it? There's a space after the comma, type opened. Right. So let's say if that type opened, and we also increment C plus plus C. Okay, let's put a breakpoint down here. So let's skip over some here. There we go. Okay, so here we expect a short. Yes. Here we expect unsigned char and point. Okay, we still don't have it. It has char and point now. Oh boy. What's the problem? So it goes in here. Right. Hmm. Maybe we need to put here need to put this here. Okay, so an if is space. How about we merge this together? We say put this here. If not, type empty, push back. And put also continue here. And then we remove this one here. Okay, how about that? Well, what if we have a type like long, long? Long, long. I think that's still not quite right. How about we how about we go in here and we put a std vector std string function parameter types. Yeah. Then we make this here a static function. Put here const std string function parameters. All right. Function parameters. There we go. There we go. Function parameters. Okay. And then we go to MachO reader. And then here we do function dot function parameter types equals demangler function dot get parameter types function dot function parameters. There we go. There we go. Okay, let's see. Function parameters. Okay, and then here we do function dot function parameter types. There we go, because it's already computed, so we don't need to recompute it. Okay. Let's look over this list here. Functions, watch. Oh, this is slow. Okay. Okay, so functions, and we are looking at this guy here. Okay, function parameter types. We have 2, unsigned char and point. Okay, let's look at some others. What about this one here? We have a CF string and char. Yeah, okay. What about this one here? CF string, unsigned char. Unsigned long. Let's see this one. FS ref. Unsigned long. FS ref. Okay. Okay, let's keep looking around a little bit. Oh, this one looks tricky. There's a void. No, that's not correct. Well, actually, it is correct. We have a sample type and we have a void type, so that's correct. Yeah. By chance. Okay. Okay, here we have 3 floats. Yeah, 3 floats. Oops. Okay. I'd like to see some long or something like that. Long int. I guess it doesn't matter much. What about this one here? That one looks atrocious. Oh boy. Well. Okay, so this is not quite right because of the commas. Can we fix that easily? Oh boy. Type opened. Let's say bool in template list false. So we say if in template list, it should probably be an integer. Template list 0. We do if c equals this, then we do in template list plus plus. Continue, and then we say if, and we can do also else if c equals close. Oh boy. Minus template list. Continue. And then we say this if template list equals 0, only then we do these checks here. There we go. We can say also else here, else if. Okay, let's see if that works. All right, let's see. Functions. We looked at 433, right? 433 here. Parameters. Oh boy. Parameter types 2. It's missing now those. Oh, I see. I see. Where are we? Yeah. I think we need to just remove these guys here. Oh, we have some problem here. How? Four, three, three. Okay. This looks good now. Parameters. Oh boy. Yeah. Yeah, okay. So this one is point. This one is C display info. Now, okay. Let's assume that this I did this correct without errors. How about we comment out this one and see if we get enough hits here that we don't need this anymore. Maybe. Let's put a breakpoint here. Let's put a breakpoint down here. Okay. Okay, this could be really expensive now. Well, not as expensive as it was before because we don't recompute it every time. But still, this needs to look into each of these and compare them. Yeah. Okay, what do we have here? STD. Okay, it's certainly not a class, yeah. Okay. Mac tools, not a class. Good. STD, not a class. Mac preferences, Mac resources, Mac folders, STD, Mac files, Mac builder, Mac memory, Mac Big Mac, Mac debug, Mac log file, STD, Mac display, STD. Why don't we get a hit here? What's going on? STD. STD, Mac features, STD, Mac strings, var buffer. Okay, C open GLM matrix. This one is used as a parameter. Excellent. So we do get a hit here. Okay, so this is then definitely not a guess, and we don't need to check this one, at least for this case. Okay, here we have another one. ctext stage. Name ctext stage. Yeah, okay. Functions, function. Let me see. Function parameter types 2. There we go. Okay, cool. That works very well. STD is namespace, STD. Okay, ctext unit is also used as a function argument. Excellent, excellent, excellent. Okay. What do we have here? STD again. STD, 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 STD. Lots of STDs. It's okay, we go through it. Okay, okay. All right, that looks good. That looks very good. Matrix ready. Oh, this one looks like a class to me. Uh-oh. Ah, it's sitting here. Okay, good. It is a parameter type. It is a class. Very nice. Good. There we go. STD. Okay, so far it looks really, really good, and we don't need this abomination anymore. That's also good. Ah, multi-ini field pass. Ah, okay, that's also a type. Yeah, okay, very good. SCD, SCD, SCD. Very good. Very, very, very good. GNU is CXX. Yeah, 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 yeah. Oh boy. How about we say if name is not std and name is not GNU CXX. Okay. Then int a equals 0. Put breakpoint in here. Remove this one. Let's start again. All right, there we go. So Mac tools is treated as a namespace, 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 fair, 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 fair. Yep, yep, yep. Var buffer. Okay, let's remove this here and let's see what else is being treated as a namespace. CSC is namespace, okay. Static name key, uh-oh. What is that? Static name key. Static name key. Well, could be a namespace, yeah. Yeah, could be a namespace, we don't know. Yeah. Okay, that's fair. Game client random variable. Oh boy, what is that? Copy value. Could be a class or not. What is it in Thyme? In Thyme it is a class. It is a class because it has members. Look at that. Oof. Yeah. Yeah, that's a good question. How do we deal with this? I don't know. There's no clue as to that this could be a class. It's not used as an argument. It doesn't have constructor. Okay, but I guess it's not a big deal because it's simple to change from namespace to class and manually, right? Or we just hard code it and say that this is also a class. Yeah. Okay, how about we hard code some of these things here? It's pretty dirty, but okay, so we got this guy, copy value. I mean, it's a bit shitty. But I don't have any better idea. Not at all. Static name key, that is also a class. What else? Game logic random variable is probably also a class. Yeah. Yeah. What else? Map cache. Looks also like a class, if you ask me. Map cache. I'm surprised that... Oh, but this one has inheritance. Why is it... Hold on. That is weird. Map cache. We have a static here. So from static we also know... Yeah, okay, so there's still a lot, some false positives. Yeah. How about we let this run through. Waypoint map, parabolic ease. Yeah, so it looks like we get a lot of things now. What is this? BW render class is expected class. Oof. Output light struct. That's not a... That's not a namespace. Collision math. Okay, let's see how much namespaces we have. And there are probably a bunch of false positives in there. Yeah, namespaces. 59. Yeah. Yeah, we have a bunch of classes in here. We have a struct in here. Class. Okay, so everything that ends with class or struct is probably not a not a namespace. Okay, so maybe we can still do something with a name. Yeah, if it ends on a class, and it's very likely a class. But we also have things that don't end on class. Missing texture. Oh boy. Yeah. Okay, well, it's not too many things. Just 59. How many classes do we have? 2,107. Wow. Okay. That's a lot. 2,107. Yeah. Okay, but I think what we have so far is not bad, I would say, because it's hard to argue against these two methods, right? If a name has a constructor or destructor, then it's certainly a class. if it is used in a function argument, then that's also very strong evidence. There is one more thing that could be done, but we don't have it yet, and that is if we know that we have a... Ah, no, that's not true. That's not true. If we have a variable inside some name, then that could also be a namespace or a class, right? Yeah. So I think we have to put some heuristics and make some guesses. But okay, the class and the struct ones, I think they are pretty clear. The rest we can maybe hard code. Like texture loader is very likely a class. WW3D, I don't know. Could be a namespace. WW3D. How to say? Let's search for this name. It's not in here, but it's probably a namespace. I would just guess. WW3D. Oh, could be also a class, to be honest. Could be a class. Could be a namespace. Huh. I don't know. Okay, how about we take a break now and then try to figure out later more. What, 3 hours already? Okay, that was a long session. Yeah, but we got quite a number of things done, so that's good. But there's still more to do. It's quite complicated. Yeah. Okay, but we are inching forward. That's good. All right, have a good day or night. Until next time, goodbye.